Hi guys, today's lesson is on probability and odds. We've already talked a good bit about probability, probability being the ratio of the chances of winning or something happening over the total. But now we're going to talk about odds, which are slightly different. You may have heard about odds, especially when it comes to like winning in particular games or raffles. So what does it actually mean to say that the odds of winning are 1 to 5. Odds are a little bit different. This does not mean that there is a 1 out of 5 chance of winning. I want to make that clear. So 1 to 5 as odds is not the same as 1 out of 5 in a probability. So make sure that you're writing these down in your notebook. Pause if you need to. But let's talk about the difference between odds and probabilities. You need these two definitions. So odds are a ratio of the number of desired outcome, for instance, wins, to the undesired outcomes, maybe losses. So it's the number of ways something can happen to the number of ways it does not happen, whereas probability is the desired outcomes to total possible outcomes. Okay, so the difference is that second number for probability is always out of a total. When we say something has a 1 out of 5 chance of happening, there are 5 total ways it can happen, and only 1 fits our description. Odds are a ratio of like wins to losses. So make sure that you have that written down, and we're going to go ahead and practice with some of that. So let's go back to that original question. What does it mean to say the odds of winning are 1 to 5? Well, what it means is that for every one person that wins, 5 people would lose. Okay, it's not 1 out of 5 total. It's for every one that wins, 5 others are not going to win. So if we then want to answer the question, what is the probability of winning? Since odds are not a probability, it'll help to draw a picture with this. So if for every one person that wins, let's represent them with a W, there are 5 people that will lose. So if I had this as a question with probability, and I said, well, we have 1 winner, 5 losers, what is the probability that you win? Well, in this case, there's 1 winner out of a total of 6 people. 6 outcomes. So the probability of winning is 1 out of 6. Okay, and we're going to leave these as fractions for now. You could get a percentage if you wanted to do that and divide the top by the bottom, but we're going to mostly, for this lesson, leave probabilities in fraction form. Okay, and that's really as simple as it gets. We're going to practice going back and forth between odds and probability to make sure you understand the difference, but they don't get super complicated. So let's look at another example like that. If the odds of an event occurring are 2 to 3, the event occurring, just FYI, this is always your first number. So that means there are 2 ways that it does occur. So in this case, there are 2 ways that it does occur. I'll indicate those with a check. And there are 3 ways it does not occur. It doesn't matter what the event is. We could think of it as wins and losses in a game. But that's what this looks like. There are 2 ways that it occurs, 3 ways it does not. So then we could also say, what are the odds of the event not occurring? So the odds that the event does not occur just means we have to put the number of ways it does not happen first. So there are 3 ways it does not happen, compared to 2 ways that it does. It's just a reverse of the original odds that we did. So then what is the probability that the event occurs? The probability is a little bit different. Probability is out of a total. So the number of ways that it does occur is 2. Out of a total is 1, 2, 3, 4, 5. So the probability that it occurs is 2 out of 5. And then the last question, the probability that the event does not occur, just changes our top number. The ways that it does not happen is 3. There are 3 sort of failures, you could think of it as, still out of a total of 5 for probability. So those are the types of questions you'll be going back and forth between. let's have you try one on your own. Okay, so the odds of an event not occurring, so read very carefully, the odds of an event not occurring are 4 to 3. I want you to pause this video and try to answer these 3 questions on your own right now. Okay, so let's look at this. The odds that it's not occurring is 4 to 3. That means there are 4 ways that it fails, does not occur, and 3 ways that it does. These pictures help a lot, especially in the beginning. So the odds that it does occur is just going to be the reverse of this, 3 to 4. There are 3 ways it does occur, 4 ways it doesn't. The probability that it does occur, pay attention to your wording. You got to know which one. So that's your check marks. That's your successes. There are 3 ways it occurs out of a total of 7. Probability is always out of your total. And then the probability that it does not occur, that's the X's. There are 4 failures out of a total of 7. So that's your probability. Okay. Now this one's going to start with a probability. So we'll do this one together and then you can do one on your own. So if the probability of an event occurring is 3 out of 8, that means 8 is your total. So keep that in mind. If it's a probability, this has to be your total. So if you wanted to draw a picture like we did in the last ones, we have 3 successes out of a total of 8. So I do this until I get up to 8. 4, 5, 6, 7, 8. There must be 5 ways that it doesn't occur so that there is a total. There's definitely 3 successes and a total of 8. So fill in the rest with X's. Okay, so the odds that the event does occur, that means we put the ways it succeeds first, 3, and there are 5 ways it doesn't succeed. The odds the event does not occur, that's the reverse of A, so that's 5 first, 3 second. And the probability that the event does not occur, so that's 5. That means we use the unsuccessful attempts, the failures, 5 out of a total 8. Okay, so you try one on your own. The probability of an event occurring is 7 out of 10. Answer these 3 questions, pause your video, and then come back to check with me. Okay, let's go ahead and do a quick check here. So if the probability of an event occurring is 7 out of 10, that means we would have 7 successful attempts out of a total of 10. So 3 would be unsuccessful to make that total. So the probability the event does not occur is 3 out of 10. The odds that the event does not occur, put the unsuccessful attempts first, 3, write it as a ratio. You can still write these as fractions, that's okay, but I like putting the colon to separate probabilities from odds so we don't mix them up. 3 to 7. And then what are the odds the event does occur? That's a 7 to 3. Put the successes, the ways it does occur first. Okay, so let's do kind of a recap here. Some probability and some odds questions. So I'll do the first 2 with you, and then we'll have you pause and try the next 3 on your own. All right, so we're thinking of choosing a random card from a deck of cards without replacing if we're going to pull more than one. That means if we're pulling more than one, we're not putting the first card back before pulling the next one. So if you're not familiar with a deck of cards, you might want to pause it and go on Google and search for a list of cards and the way they are played out. For probability questions, you really need to understand like how many red cards there are, how many jacks are in a deck, and that kind of thing, because these are common questions with probability and odds. Okay, so we're going to do anytime you see this P with a parenthesis, that's a probability question, so keep that in mind. This is the probability that we're picking 2 cards. The first one is a king, and the second one is a queen. So we don't have jokers in this deck, so we have a 52 card deck, which is standard. If you don't know this, there are 4 kings in a deck of cards, so the probability that that first event happens is 4 out of 52. The probability of the second event happening, keep in mind, you have to assume you've pulled a king out of the deck in that first draw. So how many queens are left? There are still 4 queens, but now there's only 51 cards in the deck. Now, I strongly recommend you simplify before you multiply. The rule is we multiply these probabilities together. So 4 out of 52 can be simplified. They both can be divided by 4. So that will, let me rewrite that off to the side over here. Give me one sec. All right, so that's going to be 1 when we divide by 4 out of 13. And we cannot simplify 4 out of 51. So this ends up being 4 out of whatever 13 times 51 is, which is, you can definitely use a calculator for this, 663. That is your probability for A, 4 out of 663. And it comes from doing this, 4 out of 52 times 4 out of 51. Okay, the odds of pulling a red card. Okay, well, half of them are red, half of them are black, if you didn't know that. Now, unsimplified, I'm going to go ahead and write this out, unsimplified. That means out of the 52 cards, 26 are red, 26 are black. So the odds would be 26 to 26, but you do have to simplify odds just like if it were a fraction. If you had written it as a fraction, 26 over 26, you would have to simplify it. The difference is with odds, because it is a ratio, we have to keep it as a fraction, or with the colon, we cannot simplify it to a whole number. So when we divide the top and bottom by 26, we get 1 over 1. We cannot just write that as 1, which is one reason why I like to keep writing it in this form. It's a little bit more clear that you need both of those numbers for this ratio. So we call that a ratio of 1 to 1. And that's an important concept you might want to jot down in your notes. If we have a ratio of 1 to 1, that means it is equally likely to pull the red card or the black card, or for either event to occur. It's equally likely. It's a 50-50 chance. So if we had to do probability with that, we'd say it's a 1 out of 2, 1/2 chance of that occurring. Okay, so I want you to do the next 3. There's 2 probability and an odds question. So pause this video right now and then come back when you're done and we'll check. All right, let's go ahead and check this. So probability of pulling a black card and then another black card. So there are 26 black cards. I'm going to put it unsimplified first. So 26 black cards out of 52, that's the probability of picking a black, times, now that I have to assume I picked a black card and didn't put it back, now there's only 25 black cards and only 51 in total. Now this 26 over 52 can be simplified, and you might have immediately wrote it as 1/2 because the probability of picking a black card is 1 out of 2 since half of them are black. So that probability is, the other one cannot be simplified, 25 out of 51 times 2, 102. That's your probability for C. All right, let's do D. The odds of not pulling a red jack. Well, if you didn't know, there are 2 red jacks in the deck. So if we're looking at our probability, or our odds, not pulling a red jack would go first, pulling a red jack would go second. So I'm going to put that 2 for the 2 red jacks in the second spot. And all the rest of the cards would work. All the rest of the cards are not red jacks. So that means 50 are not. Now you do have to simplify that. So we're going to divide them both by 2 and say that's 25 to 1. That's your odds of not picking a red jack, 25 to 1. All right, and this last one, picking 3 aces. So there are 4 aces in a deck of 52 cards. So the probability that we pick an ace first is 4 out of 52. Remember, we've picked an ace out for that second one and not put it back. So now there are 3 aces out of 51 cards. And then when we pick that third one, we've already taken 2 aces out at this point. So there are 2 left and only 50 cards in total. Definitely want to simplify these first to make things easier. These are both divisible by 4. That ends up being 1 out of 13. If you didn't catch this, they are both divisible by 3, so you can simplify this as well. 1 out of 17 and 1 out of 25. And you can multiply that on your calculator. That ends up being 1 out of 5,525. And that's a good review of both probability and odds for you.